Hey, hello again, everybody. We are going to pick up in this video where we left off with the Algebra 2 Regents June 2023 exam, which was question 25. So I'm going to go down to 25. This is the part of the exam where we're starting to get partial credit. So for all of these questions, you want to try and show as much work as possible. And the part 2 questions that we're going to start with are 2 points each. So be very careful that you read the directions. If it tells you to round, make sure you're rounding correctly. And again, just show all work. So let's start with number 25. So 25 is a statistics question, so it's a little wordy. It says the business office of a local college wishes to determine the methods of payment that will be used by students when buying books at the beginning of a semester. Explain, remember, explain on this exam means you have to use words. So we're going to have a written out answer. Explain how the office can gather an appropriate sample that minimizes bias. So anytime a question for statistics is talking or asking you to come up with like an experiment or a sample or some kind of study or anything, you have to write the word random. So an appropriate sample would be the group that we are giving this survey or experiment study to. This part right here was just to kind of give you a hint to minimize bias. Remember, bias is like unfairness. It'd be like going to a football practice and asking the kids what their favorite sport is. That would, of course, lead to some bias. Everyone's probably going to say football, or at least most people will. That would be very biased. To get an unbiased response, you want it to be as random as possible. So maybe asking all students that enter the building for school that day what their favorite sport is. Then you get a mix of a fair sample. So what this question is asking is about a local college and the students and how they will be paying for their books. So the first thing I'm going to say is maybe we are going to pick random students. Remember, this is an open-ended question too, so that's why I really stress this word random. There's a lot of freedom in this answer. So I'm going to say pick random students on campus and just ask them what method of payment they will use when buying books. So again, like I said, there's a lot of freedom with this answer. That's just a very vague sample. You could maybe give a survey to random students electronically, asking them what method of payment they will use when buying books. You can, as long as you say that word random and you try to steer clear of like separating to just a certain group, like you don't want to just ask the students in the library. You don't want to just ask the people in their first year of college. Like you want to be as broad and random and spread out as possible. Okay, so that word random was huge. So make sure in your explanation you do have that word random to show that you are getting a good sample and minimizing bias. All right, number 26. Determine the solution of the square root of 3x plus 7 equals x minus 1. So I have an x on both sides, but what I'm noticing here is this is a square root equation. So if it's a square root equation, I have to start by getting rid of the square root. The opposite of square rooting is squaring, so I have to put a squared here so that the square root and the squared will cancel, and I don't have that square root there anymore. But remember, what you do to one side, you have to do to the other side, and I mean the whole side. So I'm going to put parentheses there and square that right side. So on the left side, because the square root and the squared canceled, I don't have any of that anymore. It's just 3x plus 7 that's going to come down. On the right side, when you are squaring something, it means you are going to write it twice. So I'm going to write that x minus 1 and multiply it by itself, hence the definition of squaring, by writing it twice. And now I just have an equation to solve. So the next part that I'm going to have to do is that blue part on the right side. I have to double distribute that out. So I'm going to have to multiply all of this out, which means that this is going to stay the same for now. This will be x times x, which is x squared. Again, I always shortcut this step. So x times negative 1 is negative 1x. Negative 1 times x is another negative 1x. So what I'm doing in my head is negative 1x and negative 1x. Combine those to get negative 2x. You don't have to do it in your head. It's just a quick little step. And then last is negative 1 times negative 1, which is plus 1. Now what you have to remember is when you have an x squared and an x in your equation, you can't just use your solving for x steps, you have to factor. So I want to get this equal to 0 before I start factoring. Now what's going to happen here is to get this equal to 0, you do not want to move the x squared this way. What I just wrote is what you don't want to do, because if you move that x squared over to the left side, it's going to be a negative x squared, and you'll have to do the trinomial AC method. We want to do trinomial easy, which requires a positive 1 in front of that x squared. So I want to move this stuff this way. So I'm still equal to 0. I just moved the easier stuff to the other side. Oops. So it'll be x squared. I'm going to combine my x's. It'll be minus 5x. Combine these numbers, I get minus 6, and that equals 0. So now I have to factor this. So easy trinomial tells me I have to figure out what multiplies to negative 6 and adds to this middle number, which is negative 5. This is one of those tricky ones where you have to be careful because, like, technically when you're looking at your pairs, there's no obvious one to what it couldn't be. It's either 1 or 6 and 2 and 3. For it to be 2 and 3 and add to a negative 5, it would need to be a negative 2 and a negative 3. When I add those together, I do get negative 5, but negative 2 times negative 3 is a positive 6, and that's not what we have. But you do have to try it out just to see. So it can't be negative 2 and negative 3. It has to be 1 and 6. And for it to add to that middle number of negative 5, it'll have to be a positive 1 and a negative 6. So my factors are going to be x plus 1 and x minus 6. And then that's done being factored, but remember we are solving, find the solution. So I'm going to tee this up, and then I get negative 1 and 6. Now, when you are solving a square root equation, this is one of those situations where you have to check for extraneous solutions or rejected solutions. So you have to check them back in your original equation. So your original was before I put any marks on it, this one right here. So to check my to check negative 1, I'm going to plug negative 1 in for x in this equation. So here and here. So it's going to be the square root of 3 times negative 1 plus 7 equals another x, so negative 1 minus 1. So I'm going to do this math. On the left side, that gets me the square root of 4. Negative 1 minus 1 is a negative 2. The square root of 4 is 2, which does not equal negative 2. That does not work. Remember what we talked about in class? When you do have a square root, technically it is plus or minus, but that's only when you're solving for x. And it's asking you, like, what are the solutions of x? That's not what we're doing here. We are checking 2 does not equal negative 2, so that means this answer rejects. Please write rejects to show your work and say that that is not a solution. Now, I do still need to check 6 because sometimes both answers will reject. So this one is 3x plus 7, so I'll do 3 times 6 plus 7, and that equals x minus 1, so 6 minus 1. Okay. So I'm going to simplify this side. 18 plus 7 is 25. On the right side, I get 5. The square root of 25 is 5. 5 does equal 5. Now, what I've seen a lot of people do, please be so careful with this. I've seen people accidentally be like, oh, the answer is 5. The answer is not 5. Remember, 5 was to get you the check. Your answer is 6. So be careful. Your final answer is x equals 6. So you can put it in your squiggly wigglies. You don't have to because there's only one solution. Just in some way label that 6 is the only answer and negative 1 is not an answer by writing reject. All right. Also, what I would like... Never mind. I was going to go over the check with you again, but you have to check it anyway, so not a big deal. Number 27. This is a tough question for a lot of people, so stick with me. 27 says the population of bacteria P of T in hundreds after T hours can be modeled by the function P of T equals blah. Determine whether the population is increasing or decreasing over time. Explain your reasoning. So to my students, we have done this so many times on our weekly reviews on Delta Math. But I know you guys hate these questions. So to figure out if it's increasing or decreasing, we want to think about the growth and decay formula. So the growth and decay formula is this. Now, I don't know if it's growth or decay, but what I do know is to figure out if it's growth or decay, I have to look at this number. This number will tell you whether it's growth or decay, because if it's bigger than 1, it would have been 1 plus something, which is growth. If it's smaller than 1, it would have been 1 minus something, that R value, which is decay. So I need to be looking at that number. Now, in this equation, in this format, see how it's only raised to the t. So to figure out what that boxed in number in red is going to be, This equation that's given in the problem can only be raised to the t, and it's not. There's other numbers up there. So what we have to do is raise that e to this number to figure out if it's growth or decay, 1 plus r or 1 minus r. Now that 37, I don't care what number that is the starting amount. It has nothing to do with a question like this where you're figuring out whether it's growth or decay. That part all comes from that boxed in red 1 plus or minus r. So in your calculator, you're going to type in e, which is second divide, and then raise that to the 0.0532. Because again, I'm trying to get it to just the t, so that part in red is what I'm trying to plug into my calculator. So this equation becomes P of t equals, still 37, but we don't care, times that number that I boxed in is now 1.05464 blah, blah, blah to the t. So now it's just raised to the t, which matches up with this, which means that this number now matches up with this. And it's 1.05, which is bigger than 1. This came from 1 plus r. So because it's 1 plus r, it has to be growth, which means it is increasing. So to answer the question, determine whether it's increasing or decreasing, I'm going to say increasing. And then you just have to explain. So you're going to say because I don't know how to like word it for you guys. That would be best. Because you are multiplying. Oh, there we go. Because you are multiplying 37 by a number greater than 1, which represents growth. Now, I showed you that way first because that's the way most people did it, I think, when they took this exam, if I remember correctly when I was grading it. Also, I feel like we did that the most in class. But if you look at the directions, nowhere in the problem did it say to show your work algebraically. So for this question, you could have done it graphically. So I'm going to show you another way. This is not as well. This is instead of, if you didn't really care for that method. So for graphically, you could graph it. I'm going to go to the y equals in the calculator, clear out all of my stuff, and type this equation in. So I'm going to type in 37 e to the 0.0532x, and then hit graph. Now you're going to have to change your window. That is not working nicely. So I'm going to change my window. I'm going to do zoom fit first, which is zoom 0. If you don't know zoom fit, so we've talked about this in class, but zoom 6 takes you back to that 10 by 10 window. If you hit zoom 0, it's called zoom fit, and it tries to give you a good representation of a good window so you can at least see your graph. It kind of like shows you where it's going to be. So I can see right now that I couldn't see the graph originally because it's going up to like 40, 50, 60. So that's why my window wasn't really working out so great. So I can change this around now. Like I can make this a 0, maybe make this like a 70. You don't have to, but it just kind of makes that window nicer. So because we have to like show our work and explain our reasoning, you're going to have to provide a sketch of the graph. It does not need to be perfect by any means. So I'm just going to sketch this like so. Whoop. Okay, does not need to be perfect. But just like when we did it algebraically, you do have to explain, and remember, explain means you have to use your words. So you can't just show a graph and be like, increasing, end of sentence. If it said justify, you could, but words always helps. You always want to add that extra little bit in. So this one would, of course, be increasing. I'm hoping we're seeing that. If not, here it is. When you look at the graph from left to right, as time is increasing, the value is increasing of the graph because it's going up. So that would mean that the population is going up as time is going up. So we're going to say on the graph, it's increasing because the graph is going up, increasing. You could even go as far as to say as time increases on the graph, population increases. Again, these are a lot of different ways of explaining it. You do not need to write all of these out. It was just a bunch of different examples. If you preferred algebraically, stick with that. If you prefer graphically, you can only do that because the problem didn't say algebraically. Just use your resources wisely. All right, let's jump to 28. I really loved the question 28 because I'm a math nerd. But it asks something that we've learned in class in a slightly different way. So it says the polynomial function g of x has a factor of x minus 3. Determine the value of a. So the first thing I think a lot of us might try to do is factor. It's not going to work for factoring. Okay, if you try to factor, you're going to do grouping. I'll even show you real quick because I think a lot of you would try to do it as soon as you see that word factor. The GCF of the first group would be x squared, and that would leave you with x plus a. And then there is no GCF here, so you would take out a 1, and you're left with a negative 5x plus 6. These do not match at all. So factoring is not going to work. If you tried it, great. I love that you tried that first. But again, when it doesn't work, you've got to have a backup plan. So the backup plan for this question is to think about another thing that we did this year when we talked about something being a factor. And that thing is long division, specifically the remainder theorem. Just kind of putting you in the right mind space. So we were doing long division, the remainder theorem. For something to be a factor when you did long division, you would do all of this, you'd get an answer, you'd blah, 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 blah. For it to be a factor meant you got a remainder of 0 at the end. If you got a remainder of 0 at the end, that meant that this evenly went into this with nothing left over. So that would mean that this would be a factor of this because, again, it evenly divided into it. So with that in mind, we can't really do long division because I have this a here. So we have to use the remainder theorem. So that what the remainder theorem tells you is that you want to take what you're dividing by, which for this one has to be that x minus 3, and plug in what you would get when you tee that up. So if you teed this up, you would get x equals 3. That means you have to plug in 3 to your original expression. So if the question was asking you to find the remainder, you would plug in 3 to that original expression. So where it says x to the third, I'm going to plug in a 3 to the third plus a times 3 squared minus 5 times 3 plus 6. Now, when you plug that into your calculator, it will get you the remainder. That's the remainder theorem. Again, you just plug this number into the original. It spits out the remainder. But this question is not asking you for the remainder. It's asking what a is if x minus 3 is a factor. It's telling you in the problem that x minus 3 is a factor. So what you have to know is for it to be a factor, the remainder is going to be equal to 0. So in code, this question is telling you what the remainder is, and the remainder is 0. So you are going to set your equation when you plug 3 into it equal to 0. Because again, when you plug in 3, it's supposed to give you the remainder. We know the remainder, so we're plugging that in, and we're going to use that information to help us solve for a. So now this is just an equation that I'm going to have to solve for a. So here I go in my calculator. This is the one thing that I can't combine like terms with. Everything else can. So I'm going to do 3 to the third minus 5 times 3 plus 6. And then I'm also going to simplify this. 3 to the second power is 9, so that'll be 9a plus 18 equals 0. So now I'm going to just solve this equation. Subtract the 18 over. I get 9a equals negative 18. Divide by 9, and I get a equals negative 2. So what that tells me is that my answer, find the value of a, is negative 2. And if I put a negative 2 in here, it would get me a remainder of 0. So you can always check your answer by actually writing out the equation. X to the third minus 2x squared minus 5x plus 6. Again, this is a check. This is not part of the answer. It was asking what is a. This is the answer. If you wanted to do a quick little check, you can do a lot of things, actually. You can graph this. It'll cross the x-axis at 3. So I'll show you that real quick. This is x to the third minus 2x squared minus 5x plus 6. When I hit graph, when I change my window back using zoom 6, I do see that it crosses the x-axis at 3, which means that x minus 3 was a factor, x equals 3 is a solution, or you could do the remainder theorem again and just plug in your 3 and make sure it equals 0. So if I plug in 3 to the third minus 2 times 3 squared minus 5 times 3 plus 6, I will get a remainder of 0. But knowing the remainder theorem in and out was really important for this question. Sometimes on the exam, they don't just ask you specifically, do the remainder theorem. It's in code, and you have to figure out what you know and use it to your advantage. Right. Number 29, recursive formula. There is a formula for recursive. The big idea is that recursive has to have 2 parts of its equation, okay? You have to have 2 parts for a recursive formula. So the way that we memorize it in class is that you are always going to write A1 equals. That is the first part, and then of course you're going to have to fill in the blank with what it is. And then your second part is always going to be set up AN equals AN minus 1. Remember, this means the previous term, and then you have to apply the pattern to it. So this is also like a fill in the blank after it, but it's going to be like plus or times, maybe divided by, maybe minus your pattern. So whatever this is going to change depending on what the actual sequence is. But that's the overall idea of the formula. So I'm going to start with A1. It's the easiest part. So when I'm writing my answer, A1 equals the first term, which is right here, 189. This is my A1 because it's the very first term. Now to set up the second part is going to always be AN equals AN minus 1. So again, what that's telling you is to find any term, you're going to take the previous term and do blah to it. So we have to figure out what the pattern is here to get from 189 to 63 to 21 to 7. Now, this is definitely a geometric sequence because it's going down very quickly. We went from almost 200 to 7 in just a few jumps. That's a very big, like, jump. But to tell for sure, you can always check to see if it's an adding pattern, like to figure out what you're adding to 21 to get to 7. You would do 7 minus 21. That means I'm subtracting 14, and I'm certainly not subtracting 14. If I did 189 minus 14, 189 minus 14, I do not get 63. Okay, so this is not an adding pattern. It's going to be a multiplying pattern. For this one, dividing, it doesn't really matter how you write it out, but you do have to figure out what you're multiplying / dividing by. I like to look at the smaller numbers to figure it out. I think it's a little bit more in your face, but you can always do the trick in the calculator, which I'll show you in a second. To do some mental math here, to get from 21 to 7, we are dividing by 3, which is the same as multiplying by 1/3. Either answer is correct. Dividing by 3 or multiplying by 1/3 will get you from one number to the next. Now you do want to make sure that's the pattern for all of them. So 189 divided by 3, there's my 63, divided by 3, 21, divided by 3, 7. So the pattern is divided by 3. If you could not tell, because sometimes on the exam it does give you tougher numbers, you've probably seen in previous examples. If you can't figure out just by looking at it what you're dividing by, the trick to find the pattern is to take your second term and divide it by your first, or any of them. You could do the third divided by the second, the fourth divided by the third. Anything divided by the term in front of it will get you your multiplying pattern. So for this one, it would have been 63 divided by 189, and 63 divided by 189 gets you 0.33333. When you math enter it, it is 1/3, which shows you what you are multiplying by, which again, multiplying by 1/3. So you can write times 1/3. That's a correct answer. You can write divided by 3. Also a correct answer. It does not matter as long as mathematically it is following one of those two patterns, times 1/3 or divided by 3, and you have this set up for everything else with 2 parts and this previous term with the AN set up. All right, let's jump to number 30. Number 30 says solve algebraically for x to the nearest thousandth. So I'm solving this equation for x. I look at the equation and I see x is up in the exponent. We have talked about this so much this year. When x is in the exponent, you have to use logs to solve it. Now you can always use log, but when there is an e in your equation, there's a shortcut if you use the natural log instead. There's no incorrect log, it does not matter, but again, shortcut for ln, so I'm going to do ln for this one. But again, I knew I had to use logs because of the x in the exponent. Now, to be able to use logs, you can only have one number raised to that exponent. So since there's no parentheses here saying that the 2 and the e are both being raised, that means that only the e is being raised to this exponent. So your first step is to get rid of that number out in front. Since the 2 is being multiplied to that, I'm going to divide to get rid of it. So I have to get that one number, which is e, raised to the variable by itself. And then 15 divided by 2 is going to get me 7.5, or you can leave it as 15 over 2. It does not make a difference. Usually if it's an ugly decimal, you might prefer the fraction, but again, either way is fine as long as if you use the decimal, you use the whole thing. So to do logs, specifically for this one, natural logs, I'm going to write the ln on both sides. So what you do to one side, you do to the other. And then I know typically in class we've been skipping this red step. You don't have to write this step, but what you do have to do is when you take the ln of both sides, take that exponent, and what log does is it moves the exponent to the front, so it gets it out of that exponent. Remember, I know it's really corny, but we said we chop it down from the exponent. It's a log, like a tree, chop it down. I know it's silly, but if it helps you to remember, there it is. Okay, so first, I got the number to the variable by itself. Then I took the log of both sides, and I brought that variable and the exponent to the front. Now, the reason this one has a shortcut is because of the ln of e. If you don't remember, ln of e is 1. So when you have ln e, it just cancels that out because anything times 1 doesn't change. So that's why it's a little bit of a shortcut to do the natural log, but like I said, you can always do regular log. So now to solve for x, all I have over here with the x is a 0.49, so I'm going to divide by 0.49 and then type that in. So I have the ln of 7.5 divided by 0.49, and that gets me 4.1120469,807. Please always write out your whole answer before you round. It does say in the directions to round, so it's a good sign that we got a long decimal. But just in case you accidentally round wrong, you have to have this whole answer written so you don't lose full credit on this question. Okay, so to round this to the nearest thousandth, that would be 3 places after the decimal point. I want to see if that 0 bumps this up. It does not. So my answer is 4.112. Done. Now, to check your answer, especially when you're solving an equation, you can always check by plugging it back into the original. So what you're going to do, if you want, you don't have to do the stow button. I'm going to, just because it's a little bit easier. Do 4.112, stow, x, enter. So 4.112, stow, x, enter. And then just type in the left side of the equation, 2e to the 0.49 x. So if you didn't do the stow at this point, you could just type in the 4.112 in place of x. But either way, you'll get 15. Now notice I didn't get exactly 15. The reason we didn't get exactly 15 is because I plugged in the rounded answer. This is technically your full answer that I just highlighted in blue. If you stored that for x and then plugged it back in, it would have gotten you exactly 15. I'll even show you that real quick. If I store that whole thing for x, and then type it in, I get exactly 15. So 2 different ways of checking. If you do use your rounded value, I did want to show you that so you can see. If you use your rounded value, it won't be exact, but 14.999, pretty close to 15. Okay, so that is how you could check that one, and I'm going to now move on to 31. Okay, 31 I did think was a little bit tricky just because of the types of questions we've done so far that looked like this. It says, for all values of x for which the expression is defined, write the expression below in simplest form. Can't tell you how many people were asking me questions about this one saying that they tried to do long division and it just didn't work. It is division. You can see that the top is being divided by the bottom. This is incorrect, but just to show you, if you try to do long division first, I encourage it. Great job. It's always worth a try. When you try to do long division first, remember, for long division, you're trying to figure out what needs to be written up here so that when you multiply it out, you get this. So this one's a little bit backwards. Hang on. You know what? Actually, I didn't try it this way, but I'm going to. It might actually work. Let's give it a go. So the reason it's not going to work right now and why I kind of like steered you away from it to start with is because what you're dividing by is not in standard form. So let's go ahead and put it in standard form. I'm going to just erase this and put that highest exponent first. So the negative x squared plus 3x. So what I'm going to do is, like I said, figure out what needs to go up here so that when you multiply it by this, you get this. So what I need to multiply an x squared by, sorry, a negative x squared by to get a positive 2x to the third is going to be a negative 2, right? Negative 2 times a negative 1 would get me that positive 2, and I'd have to have an x up here. So the negative 2x times the negative 2x squared does get me a positive 2x to the third, and then I do have to keep multiplying that through. So negative 2x times a 3x is going to be a minus 6x squared. But I have to subtract this whole row. So minus, and since this is already a minus, it's going to turn into a plus. So now when I combine like terms, again, this is always the goal for long division, is those cancel. When I add these together, I'm going to get 7x squared, and then I'm going to bring down the minus 18x and do the whole thing again. So I need to ask myself what needs to go up here so that when I multiply it by a negative x squared, I get a positive 7x squared. Oops. Whoa, 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 whoa. Sorry. I was just trying to clear up some stuff. So to multiply a negative 1 by something and get a 7, it's going to have to be a negative 7, because negative 7 times negative 1 does get me 7. And this is already an x squared, so I do not need to put an x up here. We're already good. So it's just going to be negative 7 times negative 1x squared will get me 7x squared. And negative 7 times a positive 3 will get me negative 21x. Sorry, I was just trying to think ahead. So I need to subtract this row. So I subtract this, these cancel, that's the goal. And then this will turn into adding, which would put me at a 3x. And it doesn't end up working. So I'm glad I went through it. I kind of forgot why it didn't work, to be completely honest, but it's always worth a try in the beginning. So why it doesn't work is because now you need to do one more round because that 9 came down. And what I need to put up here is something that needs to be multiplied through to a negative x squared to get you a 3x. It's not going to happen. You can't multiply something by a negative x squared and get yourself a 3x because I already have an x squared there. So it is worth a try. Didn't work out. What I'm going to do now is show you the correct way to do this question. But again, I would absolutely applaud you if you gave that a first go, tried to do long division, it wasn't working out. It does happen on the exam where you go to try something, it doesn't work, and then you need to like filter through your brain and figure out something else you've done that works like this. Something else that I do want to point out about the long division for this one is usually, like 99% of the time, if you have to do long division for a question, the directions will say to place your answer in quotient remainder form. This did not say that. So the fact that it didn't say quotient remainder form was your hint to not do long division. So now that we've gone over what not to do, but again, I would encourage you if you did try it, that was really good. We're going to go over what you need to do. So the other thing that we have done when we were talking about division, especially with polynomials, is to factor. This is going to be a factor cancel example. So on top, I have 4 terms. Those 4 terms don't have a GCF among all 4 of them, so I'm going to start by doing grouping, and I'm going to do it off to the side just so I don't get too caught up in the fraction. So I'm just going to rewrite it over here. Okay, so this one's grouping. I'm going to group the first 2 together, group the second 2 together. The GCF of my first group is x squared, so I'm going to take that x squared out, which will leave me with a 2x plus 1. That means I have to get a 2x plus 1 when I GCF the second group, which is going to need to be a GCF of negative 9 to make that happen. So I'm going to bring down the one they have in common, which is 2x plus 1, and then you put your 2 GCFs together for the next one, x squared minus 9. This needs to be factored again because this factors with DOPS. So the 2x plus 1 is going to stay. This will be x plus 3 and x minus 3. Okay, so that is going to be my final factored answer for the top. So I'm just going to put that over here on top, 2x plus 1, x plus 3, x minus 3. Now on the bottom, all I have on the bottom is GCF, and all they have in common is an x. I'm going to take an x out. When I take an x out, it leaves me with a 3 minus x. Now, we factored the top, we factored the bottom. When you're simplifying, you now need to cancel common factors on the top and the bottom. We talked about in classes, you always want to cancel identical factors first. There are no identical factors here. What I mean by identical factors is if there was a 2x plus 1, those would of course cancel because they're identical. But I don't have that. and I don't have any identical factors. What I do have is an x minus 3 and a 3 minus x. Those are close to being identical. They're just flip-flopped. They do still cancel. But when you cancel with that flip-flopped concept of like an x minus 3 and a 3 minus x over subtraction, you have to put a negative in your answer. So we've always just put it on top, right out front. So that would make my final answer negative 2x plus 1, x plus 3 over x. I do want to remind you, this x does not cancel with this x because you can't split up a factor. That x plus 3 is bound together. It is 1. It will only cancel with an x plus 3 or a 3 plus x, which does bring me to what I did want to also bring up for this question. If you have an x plus 3, and a 3 plus x, you do not put a negative out in front for these because x plus 3 and 3 plus x are identical. So think about it like, even if you just had a number, 2 plus 3 over 3 plus 2, that's 5 over 5. Those would cancel, they're identical. But if you had 2 minus 3 over 3 minus 2, that would be negative 1 over 1. The ones would cancel, but you would be left with that negative. So that's why when they're flip-flopped over a negative like this, we put that negative out in front to make this my final answer. Fun. Wow. Oh yeah, then this was over here. A way that you can check this question, because we were just rewriting the original expression, you can do the 2 stow x. So you can do 2 stow x, enter, type in your original, type in your answer. They should be equal to each other. So I'm going to do 2 stow x, enter. This is the same shortcut that I was, or not shortcut, but like check that I was showing you for the part 1s. Because you had multiple choice answers. And even if you don't have multiple choice answers on a part 2, it's really like you have one of your multiple choice answers and you want to check that one. So I'm going to type in the original 2x to the third plus x squared minus 18x minus 9 over 3x minus x squared. So I hit enter, and again, this number doesn't matter. You're just trying to see if it's equal to what you got. So now I'm going to type in what I got, negative 2x plus 1, x plus 3 over x. And I got the same thing. So that tells you that what your answer was is equivalent to what you got. If you forgot to put that negative out in front and you did this check, you would have seen that you got a positive here. And that might be like a big red flag to you that it's not right. And you have to remember to put that negative. That's why we do these checks. Sometimes we do forget little things like putting that negative out in front. But that's why we check. Okay, check, 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 check. In case I haven't stressed that. It's worth checking. You have 3 full hours to take this exam. It's worth the check time. But I do also want you guys to learn from this example, because there is always, not always, but there's a lot of times going to be an example where you try it one way and it doesn't work. You have to remember that that's okay. Just don't give up. There are other ways. So just filter, like I said, filter through your brain of all the things that you've learned this year. There is another way. Find that other way, okay? There's always a way. All right, to number 32. I think this is the last one that we're doing. Awesome, we're almost done. So for 32, a little wordy. It's a statistics question. It's not super tough though, at least in my opinion, okay? So for 32, it says an app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. A simulation of 500 samples of 150 students was run based on this proportion, and the results are shown below. So I just want to, just in case you didn't watch a previous video of mine, re-explain what a simulation is. So in this study, they were talking about, let me read that again, sorry. An app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. So whoever did this idea, or what they were thinking, was that 0.85. They put that information into a computer, and the computer ran a bunch of fake studies to get some fake but accurate data. So it's just kind of like, it's almost like your computer's taking an educated guess on what some data could be based on this data that was given to it. So of 500 samples, that means they ran this fake study 500 times. They pretended there were 150 students in each of those simulated studies. they came up with these results. So of course there's going to be a lot of results at that 0.85 number because that's the number that we originally started with by giving that information to the simulator in the computer. Okay, from there, they were like, here are some other realistic numbers, but notice as you go further out, they happen less often. So if you were to count the dots on here, it's 500 total dots because each of these numbers happened like during that time. So like this dot is one of the simulations, and during one of the simulations, they got 0.85 as their result. During one of the simulations, they got 0.875 as their result. This is how many times the simulator got a result of 0.875. So that's why it says frequency over there on that y-axis. So that's kind of how you read everything. But the most important part of these diagrams is the information on the top. Sometimes it's top left, sometimes it's top right, but it'll always say the mean and the standard deviation. We're going to be using that. But that's just how you kind of analyze the data here. So for the next part, it says, suppose a sample of 150 students from your high school showed that 88% of students had purchased apps on their smartphones in the past 3 months. Based on the simulation, so based on that diagram above, would the results from your high school give the app design company reason to believe their assumption was incorrect? So this was their assumption up here. When I go down, the high school actually showed that 88% of students had purchased apps on their smartphones in the past 3 months. So what we have to do is figure out if that 0.88 or 88% is reasonable, is possible, is plausible. Those are just some of the keywords we talked about in this unit. To figure out if 88 is a realistic, possible, plausible number, we have to find the confidence interval, which is also known as that middle 95%. If that 88% falls within that confidence interval in the middle 95% of data, it's incredibly likely to happen. Okay, so I need to first find my middle 95%. So that middle 95% formula needs to be memorized. It is the mean plus or minus, technically plus and minus, 2 standard deviations. So I boxed in that information above. This is what we are going to use to figure this out. So the mean is X bar. I'm going to plug that in here, 0.852 plus and minus 2 times that standard deviation symbol is SD in the table, like in the diagram that's given, and that's 0.029. So remember, I know we usually say plus or minus, but for finding the interval, you need 2 numbers. You need a number through a number, so I have to use both of those things. You are going to subtract the 2 numbers, so 0.852 minus 2 times 0.029. That'll get me my low end. I always do subtraction first because that's going to be this first number over here. Through, so that's the first number of my interval. Now I'm going to do that same thing, but with a plus. And I get 0.91. So my confidence interval, again, what that tells you is where most of your data is going to fall, aka that middle 95% of the data. So there's going to be a remaining 5% that falls over here on the outside and over here on the outside, but they're not likely to happen because they're not within that middle 95%, which is where a majority of the data is going to fall. So the wording of this question is a little bit tricky, but it says, based on the simulation, again, based on the information, would the results from your high school give the app design company reason to believe their assumption is incorrect? Their assumption was 0.85, which is also in the middle 95. That 88% is also in the middle 95. Both things are likely to happen. They are both in that middle 95. What was the words that they used? They were believing that the results would be 0.85. That 0.88 does not give them any reason to believe that their number is incorrect because both of those numbers are very close. They are both within that middle 95%. So when it asks, I kind of hate when they ask it, it's like double negative kind of idea here, but they're asking if the results would give them reason to believe that their assumption would be incorrect. The answer is going to be no, because they are not incorrect. They were very correct with their 85%, with our 88%, both being within that middle 95. So your explanation is just going to be because that 88% or 0.88 even, because we used the decimals, falls within the middle 95. And while we're talking about this question, because it is a very common question on this exam, I do want to talk about a couple other words. So remember, if it's within that middle 95%, it is a very common occurrence. It's likely to happen. It's plausible. It is like we're confident that it would happen because it's in the majority middle 95%. Of course, it's probably going to happen. 95% of the data falls in there. One of the words that represents it being outside of the middle 95% is significant. If it's asking if a number is significant, that means it's on the outside of the middle 95%. Significant kind of means like rare, unusual, another couple of words to represent being on the outside. Anything that would kind of represent that it doesn't happen often or usually is going to mean it's on the outside of that middle 95. Okay, so remember all those questions that we did were part 2s, which means that they are 2-point questions. You'll notice for some of them, you really got to spread those 2 points out. So that's why I, again, repeat that you want to make sure you show as much work as possible, check when possible, and just be very careful. And like I said, show all of your work. So if this is the last video you watch before you take the exam, good luck. If you continue with the next one, I will talk to you soon.